Hey y'all, welcome back to Radical Slice. My name is Eric. This is part 3 of my attempt to implement some old school Zelda dungeon-esque thing in Pico-8. Last time we gave our baddie some really basic AI, so he kind of wanders around a little bit. And we took care of our background collisions, so both the player and the baddie will bump up against the walls on our map. This time, we're going to begin by adding some of the combat stuff. So let's jump right in. Okay, before we do anything else, I wanted to have a quick look at our list of requirements to see how far we've gotten. So let's see, we've got hero movement is done. So let's make this a nice green color. Oh, that's nice. Collision with hero, done. Trigger weapon, nope. Health, nope. Collision with weapon, nope. Weapon active, weapon collision. Nope. Okay, so we haven't done any of these yet. So really, we haven't made that much progress. Let's try to work on the weapon stuff next. So there are a couple of things that I think will be tricky about adding the weapon. One will be the player state, since as we may remember, when Link uses his sword in the old Zelda games, he very briefly stops moving. Right? He's sort of like fixed in that one facing direction and that one set of coordinates. So you can't move around for, I don't know how many frames, some number of frames. So we'll need to add a state to our player. Just like our baddie has some states that we just did, our player is also going to have states. And our new state is going to be like attacking or something. And during that state, our player will be ignoring any button inputs while the weapon is being used. So he'll kind of pause in place, just like Link does. The second thing that I think is going to be a little bit tricky is the collision. So you might remember a little while ago, I specified that our collision had a fixed height and width of 8 pixels. You can see them hard-coded right at the top there. There's our original sin. Well, the whip is going to have different dimensions. Which you can see here, it's kind of like long and thin, like this. So we'll have to edit that collision function to account for these different dimensions. So I think I want to start with the player state changes. Right, so currently our player has one state, and that state is just, a base state of some kind. And during this state, the player is able to walk around and he collides with the enemy. The other state that we're going to want, though, is probably we'll call it attacking or ATKing because we don't have enough space to write attacking. And so the player can move from the base state to the attacking state, during which movement will be paused, so input won't be registered. And then after some number of frames, let's say like after n frames, the player will return to the base state and the weapon will disappear. Right now, our player struct or our player table doesn't have a state. I think in the baddie we had this state and we called it the initial state was init, and then we changed to what was it? Walk and wait. So for our player, we don't really need an initial state. I think we could probably begin the player in some sort of base state. So I don't know if we want to call this walk or wait because the player doesn't really have AI. So we'll just have like let's call it normal. I'll call it base. It'll match with the diagram that we just drew. We know that the weapon is probably going to be triggered by a button press. What were our buttons again? Let's say O and X. So let's say we want button O to be the weapon. I'm going to go ahead and copy that. And in our update function, we'll check for that button press. We'll say if button, I'll use button P here. Feel free to check out the Pico-8 Docs for why we're using button P instead of button. So if the player is pressing button O, then we're going to change the state of our player character to attacking. There we go. don't know if the weapon has a state or not. Let's just say it's going to have a state, and we'll call that a base state as well for now. So X and Y, we want the X and Y to be basically the player's position. So we're going to pass those in here as arguments. Let's say we want two of these sort of chain things connected to each other. So it'll be about 16 pixels long or 16 pixels high, depending on if it's the side or up and down. And actually, that's a good point. The direction that the player is facing is going to affect which sprites we use and the dimensions of the whip, right? Because you can imagine, pop over here real quick to paint. You can imagine our player guy. Let's say if here's our guy, and he's got one round foot, two round feet. If our guy's facing this way, right, then when we do the whip thing, we want the whip to kind of come out this way, like this. But if the player is facing up, for example, so look at this way now. Oh, feet. All right. Then the whip is going to kind of come out this way, right? So the way that we draw the whip is going to be impacted by the direction that the player is facing when they press the button. So we do need to include some information about the direction that we're going to be facing. So let's include that here, and we'll pass that in from the player as well. The weapon, in this case a whip, is going to assume the player's X coordinate, Y coordinate, and the direction. And depending on the direction, the width and height will change. So let's add that logic as well. Okay, that should work. So we'll go back to our button handling code and we'll say player.weapon equals new weapon, and we'll pass in the player's X, the player's Y, and the player's direction. And then we'll return here. The reason we're going to do this is because we don't want to take any more inputs if the sort of attack button is being pressed. We want to ignore directional inputs because we want the player to stop moving, you know what I'm saying? Now that we have these two different states, we want to sort of have two different sets of actions depending on the states. So and we should set a TTL. Just like with the baddie. So when the player presses the attacking button, we will, let's say it's going to take, what, 30 frames, I guess? And we'll include that up here. At the end of 30 frames, we'll have the player revert to another state. So if the player is attacking, really the only thing we need them to do is we'll just count that on the TTL. X equals 1. And if the TTL is less than 0, then we'll reset the state. Rather than having a single update function that we call regardless of the state, we'll take a look at the player's state and call the corresponding function. So we're only doing the logic that we care about depending on the state. If this all works, what we should see is whenever we press the circle button, the attack button, the player should stop and not respond to inputs briefly. I forgot one thing. The other thing we have to worry about in the attacking sort of update function, not only are we counting down the TTL, but once the TTL is back to 0 and we're resetting the player state, we want to set the weapon back to nil. I'm not actually doing anything based on this value right now, but just to prevent any bugs in the future. And let's see if we move around, and then hopefully when we hit the button, okay, yeah, that's good. So it's hard to see, but when I hit the button, it kind of stops for a brief second there and then starts up again. Back to the terminal and add that whip logic. And we'll give the whip an update function of its own. So when we call player.update, we'll also say if player.weapon is not equal to nil, then call the player's weapons update function. And let's see, when we call a new weapon, let's see here. We'll set this to be a temp variable in our new weapon function, and that's what we're going to return instead of returning it directly. And we'll give temp an update function. And we'll also give temp a draw function. So this will be interesting. We're going to draw then. We know that if the player is facing up or down, we want to use a certain sprite. So let's start with that case. So what I'm going to do here is write the drawing routine once for if it's vertical and once for if it's horizontal. Now, I can already tell that when we go to do this, the dimensions are going to look kind of funky, right? That's probably going to, the weapon's going to spawn in the player's upper left corner. That's okay. We're going to tweak that, but let's just get the thing drawn first and we'll go from there. So one thing I know I want to do here is I want to have two of these sort of whip sprites next to each other. And so I'm making two calls to the sprite function. And depending on the direction, I'm adding or subtracting 8 pixels in the Y direction. So all that's going to do is just stack two of these vertical whips, or in the left-right direction, two of the horizontal whips right next to each other. And finally, when we call player.draw, we'll do the same thing as we did in the update function. So if player.weapon not equal to nil, then player.weapon.draw. All right, so hopefully this will allow us to actually see the whip while it's being drawn. Now the problem is in the whip update function, we're not doing anything. So the whip is just gonna like stick out and then just hang out there and not go away until we press the button again. But let's load it and see how it goes. Oh, syntax error, hold on. Okay, I was missing an end at the bottom of my weapons draw function. So now hopefully this works. And let's see. Yeah, okay. So you can see the positioning is odd. Oh, and that's really broken. We're gonna have to fix that. That's completely broken, and that's completely broken. Okay, so the other one looks good. It's facing to the right. Let's fix the up and down first. I think I used the wrong sprite indexes. I should use 34 here. Let's see what I actually wrote. Oh yeah, it's just 32 all the way down. Okay, so this is totally wrong. Okay, that's what I expected. Oh God. Yeah, so obviously the whip's positioning is funky. We're gonna have to make some adjustments there. But at least the direction seems to be working okay. So let's go and make those adjustments to the positioning. We're going to have to add an additional 8 pixels or subtract 8 pixels given the player's facing. I want to do that in the new weapon function, I think. So yeah, the reason I want to do it here is just because like we're taking in the player's X and Y values at this point, and we don't want to think about them after initially repositioning them. Kind of want to just take them, adjust them as we need them to be adjusted, and then throw them away. Okay, I want to think about how to translate the player's X and Y position into the whip's X and Y position. And I'll probably have to go back and adjust these sort of transformations in the draw function too. So in the up-facing case, the whip is going to start to be drawn here, but the problem is this sprite is going to be drawn vertically downward. So we don't actually want that. We need to offset the initial Y position by 8. And actually, let's cheat a little bit. So we're going to offset the initial Y position by 2 tiles. So we're going to set it to be minus 16. And then we're just going to let it draw downward. That should make our code a little bit cleaner. I think the same thing in the left-facing case. It's going to start to be drawn here, which means it's going to like kind of draw across the player's body like this. We don't want that. So we're going to offset it initially by minus 16 in the x direction. And then we'll have another sprite minus 8 away in the x direction. Let's see how that goes. The baddie is walking on our face, so we can't move. There we go, there we go, there we go, there we go. Okay, whip looks good. Now we just need to add collision for this bad boy. And as I was saying, because the dimensions are different than the 8x8 sprites we've been working with so far, we're going to have to make some tweaks to our collision function. What I mean by tweaks is, until now, we had our hero, don't forget the feet, and our hero was 8x8. Pretend those are the same. And then we had our bad guy. Today the bad guy's pink. Okay, also 8x8. And so we can kind of do like a straight comparison where these boxes overlap, right? So if these two 8x8s overlap like this, then we know that something is wrong and there's a collision. So let me unwind this. We lost a foot. Put that back. Okay. Now, though, with the weapon, this bounding box around this is not 8x8, right? That's wrong. Instead, the bounding box is going to be more like 16 by 2, like that. So we need to pass in our dimensions to the collision function so that we know how to draw the correct box. One more thing to note here is that currently the whip is being drawn like this, but technically the position of the whip is like right here, right? This is like the sort of origin of where the whip is. So we need to offset that, right? So if the size of the sprite that we're dealing with is less than the sort of like tile size, which you remember is 8x8. Say it's 8x8 like this. There we go. pretend that's 2 tiles. Yeah, so kind of you have this empty area up here that we don't want to count as collision, because otherwise it would look super weird if the baddie is, I mean, it would be awesome if you're the player, but it would look really weird if the baddie's colliding with basically empty air. So when we do the collision check, we have to offset the Y or the X or Y position by the tile size minus the actual height of the thing. We're going to divide that whole thing by 2. And in this case, because the width is height 2, that will give us 6/2, which will give us 3. So we're going to sort of like add 3 to the Y position to start drawing the bounding box, and then it'll start like that. We'll probably also wrap this in a floor function in case there's like a decimal and we want to round it. Similarly, for the vertical case, assuming our bounding box, or our tiles rather, looks like this, we're going to want to offset this to get rid of this empty space. And we'll do the same thing, but we'll do floor of 8 minus the width. That's terrible. Let me try that again. 8 minus the width over 2. So let's give that a try. All right, I have no idea that's going to work, but we've got something in there. I guess the only way to see if it's going to work is to test it out. So let's go find where we're checking for our collision. Yeah, sounds good. All right, so in addition to checking if the player and baddie collide, actually, yeah, let's see if the player and baddie like throw this thing off. So do we have a height and width in here? No. Let's go ahead and add a height and width to our player and baddie, just to test in the most basic case if we did our collision stuff right. And type the number 8. All right. That should be good. Let's load it up and see what happens. Yeah, I mean, yeah, okay. Let's go for it. So let's check if the player's weapon collides. Now, the player's weapon could be nil here, so we're going to have to add a check for that. Which is kind of a bummer because we're exposing part of the player to the main loop, which we probably should try not to do. But again, we're in a rush. Let's try to get this done. So we want to add a separate topic here because we're sort of using collision for player and baddie. So let's have attacked for the baddie and player, or baddie and weapon rather. And in this case, the player doesn't care about the collision, but the baddie definitely does. So do handle attack. Like that. All right. So now if the player's weapon is not nil, if it exists, and if there's a collision between that weapon and the baddie, then we're going to add an attack event. And we need to write the code that's going to handle that in here. There's no handler function yet, so let's put it at the top. Handle attacks. And just so we can see if it's working or not, let's reset the baddie's X and Y position, just as like a base case. So we'll set the baddie state to init again. So we sort of reset the AI. Now, you know what? Let's banish the baddie to outside the box. Set to like 64, 64. Not even. 96, 96. That'll be really obvious, right? We're basically just kicking them right out of the right out of the box. Okay, let's see if that works. Everything's normal. 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 Yeah. Oh, yes. Come here. Yeah. Oh, no. 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 No, it's not working. Oops, our function name is wrong. Handle attacked. Okay, let's try it that. Okay, let's load this up. See if it works. Okay, baddie's in the box. Oh, there he is. He's outside. All right, good. We banished him. All right, cool. So let's make that less comical and more sensible. There's something funky about the collision from the left and from great from this side, where it's only colliding with the inner part of the whip. I think we can figure that out. Okay, so I see what's going on. With the up direction, we were actually right the first time. We want to subtract y. I'm sorry, we want to subtract 16 from y. And then when we draw, we'll start with that initial one, 16 up, and then we'll add 8. We want to move actually downward. Same thing with the left side. We want to subtract 8 and start it far out, and then the second tile will actually be 8 advanced. So I was thinking in terms of the player's position, but it's easier to think in terms of the weapon's full position. So now if we load this back up, let's see. Works, 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 works. And now let's see if, yes. Oh God, sorry guy. All right. Okay, yeah, so there are a couple bugs. One is the baddie kind of can get stuck when he respawns. The other thing that's kind of weird that was hard to catch was that if the player dies while the whip is out, the whip remains on screen. So we're going to have to fix that as well. Those are both problems, however, for another section. So let's fix those two bugs. And I guess the next thing to do would be rooms, health, and then rooms. So health and rooms next time. Hey, thanks for checking out the video. I really appreciate you giving me your time. And I hope you found some of the stuff in here helpful and that as a result, you're an even more excellent developer than when you started. If you did find any of this stuff helpful, I should say I've got a lot more of this content coming. So if you're feeling particularly generous, please give me a subscription. But either way, stay tuned and thanks again.